Hello, everyone. Welcome to our stream. Thank you for joining. We are just about ready to get started, and hopefully, y'all saw the Discord announcement. We have a very special guest joining us today, and we have some really cool technologies that we're going to explore. I see a lot of you are here today. Very excited about that because we're going to explore some super cool technologies and get to learn more about Solace Agent Mesh. Y'all saw the Discord announcement, and it's basically just a digital control center for your AI team. Uses an instant communication network, and it's going to be really cool. And we have a very special guest who's going to be talking us through Solace Agent Mesh. I'll just be your moderator for the stream. I'm Varshini from MLH. But on the topic of our special guest, let's introduce our special guest, Ray.
Hey, how's it going?
It's going great. What about you?
Not too bad, not too bad. Up here in Canada, it's nice and cold today, but I'm here to give some awesome information.
That's great. And also for those of y'all in the chat, definitely make sure you check in at the link that we have pinned. It helps you get your swag and helps us know how many people are showing up. You've got some hellos coming in, some good mornings. Ooh, a compliment for my hat. Thank you. Couple hellos. Ooh, looks like we already got someone checking in at our link. Telling everyone to do it. Thank you, Quackers and Cheese. So we're going to get started. I'm going to go off screen for now, but I'll be here helping moderate the stream. So if y'all have any questions, please make sure you ask. If it's something relevant to the stream, I'll make sure it gets answered. But if it's something a little bit that can be answered later, I'll put it in the Q&A at the end. So have a great time with Ray. It's going to be a super great stream.
Thanks so much. My name is Ray. I am a senior developer advocate at Solace. And if you haven't heard about Solace, Solace started out as an eventing platform, so event-driven architecture. That's really what we do and what we've been doing for a long time. But when the big AI boom happened, we wanted to see what that meant for us. And we came up with, I think, is a really cool framework that mixes together agentic AI and event-driven architecture. So we'll be going through the Solace Agent Mesh today. Now, what I wanted to start off with is what is agentic AI? I remember someone saying asking in the welcome ceremony, what are the different things that we're going to cover with AI? And agentic AI is kind of a big one for us at Solace. So I just kind of wanted to go through quickly what agentic AI was, and then how we are working with that at Solace. So click there. All right. So it's interesting to me to already talk about the evolution of AI. It feels like something that really hasn't been around long enough to have an evolution to it. But as we know in tech, things move very fast, right? So we started out with generative AI. At least the boom started out with generative AI. So machine learning to LLMs that solve a single problem with a specific data set. It was great, but it had some issues. So we needed to start being able to give context to the LLMs instead of having to provide it individually every time we made the call. So that's when we came up with RAG. And RAG kind of gave us the ability to provide context in order to deal with things like hallucination. But it still, required that whole concept of feeding your data into a vector database or into some sort of set where you then needed to get that context out with RAG in order to help the LLM. And then finally, we came up with the idea of agentic AI. So the idea of these autonomous systems that are allowed to make decisions and take action without humans in the loop. And by leveraging tools, they're able to accomplish these, right? So here's an example of what an agent at its base does, right? So it has a specific goal, and it's given the goal, the tools, and the memory. And then it performs actions and it observes the result, and then constantly goes through this agentic loop of performing actions and observing result until it accomplishes its goal. And then it will return with that. Now, we have this idea of an AI agent, which is kind of like a single digital assistant. It runs through a problem, plans, and adapts based on context, and then it achieves a specific goal. But what about multi-agentic systems? One agent is really cool, but what if we could have multiple agents all working towards accomplishing something, right? So these multi-agent systems work together and they divide tasks up among each other. They share information, they coordinate responsibilities, and that helps to solve complex problems. The
I think
idea.
we've got a question coming in. Someone's
Yeah,
asking,
sure.
why do we need multiple AI agents instead of one powerful agent?
I like to liken that to us as developers and the idea of the concept of a full stack developer, right? We started out being developers that were like, you could be an expert in front end or you could be an expert in back end. And then you had experts in database. And over time, we kind of got this concept of a full stack developer, which was front end and back end. And then it started expanding more. So then a full stack developer needed to know DevOps, needed to know data structures, needed to know all of this stuff. And it's really cool to be a jack of all trades, but it kind of takes away from the ability to be a master of one. So if you have several agents, you can have them specifically accomplishing individual tasks and being focused on those tasks. So instead of trying to get one agent to know everything and solve everything, we can really fine tune these individual agents to accomplish one thing.
That's great. Thank you. And I think you've got a similar question. Someone's asking, can several agents work under the same host or server?
Yeah, it's a definite possibility. That's something that I can show a little bit when we're doing our workshop, but you can have multiple agents working under one host. You can also have multiple agents pretty much sitting in every location. One of the cool parts about the Solace Agent Mesh is that you can have agents hosted out in AWS, in Google, in Azure, or even on premise, and they can all come together in the Solace Agent Mesh, which is really cool.
Those are all the questions for now. Thanks for answering.
Okay, cool. No worries. So yeah, back to this integration challenge, right? The problem of agents right now is they're very much point to point. They have one conversation with each other. And so if you have multiple agents working together, when a new agent comes in, you kind of got to make them aware of all the other agents. And it leads to this problem of all of these connections, right? So you can see the n times n minus 1 divided by 2. So if you have 10 agents, you need 45 connections in order to actually get them to all talk to each other. And this can create problems like brittle connections. So if you have agent 1 that's solving something and needs to call agent 2 that's solving something, that needs to call agent 3 that's solving something, you now have those multiple connections all HTTP streaming. And if one of them goes down, it can screw up the entire thing, right? So the solution to the point-to-point integration problem that we found is event-driven architecture. And what event-driven architecture allows, especially when working with Solace, is that instead of your agents all connecting to each other, all the agents connect to an event broker. And so when one agent comes up or goes down, the other agents don't need to have a direct connection to that new agent. They are already connected into the same event broker that the new agent is connected into. So this solves a lot of challenges, things like scalability, performance. It makes it a lot easier to work with these multiple agents, right? So you can see here with this graphic right here, we have all of these enterprise connections over on the left-hand side inside of a Solace event mesh. And then that allows agents to feed into that same mesh and have direct connections into real-time context. This is another slide that I like to go through quickly, but the challenges of adopting agentic AI. So there's the lack of the real-time context, right? There is the fact that isolated models and agents create these silos of information, especially when they're by themselves. So that's why event-driven architecture helps piece that together. Slow development can be an issue because different teams are working on their different agents and different stacks and implemented in different ways, and that can cause issues. And as we were talking about with things like brittle integrations is the asynchronous nature, right? So if agent 1 is calling agent 2, we don't know how long agent 2 is going to take to accomplish their tasks. So things like stability and user experience can really become affected. And then kind of alluding back to the previous stream with Auth0, governance and security, right? It can be a real issue when it comes to adopting agentic AI. So here's a good example of how agentic AI kind of is modeling the same thing of what happened with microservices, right? So we started out with siloed applications with these bespoke integrations that needed to happen every time we needed an integration. We moved on to microservices that were exposed via REST. And then we eventually came into these event-driven microservices. So instead of calling out individual points, you just needed to subscribe to an event happening and then take action. And the same thing is happening with agents, right? We started with these siloed agents with their individual tooling. And then we got these things like A to A and MCP and these abilities to expose these agents with open standards. And now we feel the next logical step is event-driven agentic collaboration. So this is a quick thing I like to touch on. These are kind of some of the big use cases that we've seen agentic AI is useful for. Conversational analytics, event-triggered assistance, which is a big thing for us at Solace. We're an event-driven architecture company, and agentic automation. I kind of glaze over that one whenever I get that time. So here's an example of the Solace Agent Mesh and how it works. I did not realize there was going to be this many animations to get it up and running. Is that good? Yeah, that was good. All right, back one more. Okay, so this is the Solace Agent Mesh. And you can see that in the middle here is an event mesh. And the event mesh is like a Solace event broker interconnected with other event brokers to create one big event mesh. So instead of agents connecting directly to each other, they leverage A to A and an agent proxy in order to connect into the event mesh. So they no longer need to be directly aware of all the other agents. They just need to tell the event mesh, this task needs to be accomplished, and it goes to wherever it needs to go. On the left side here, you can see we have a concept called gateways. And what the gateways are the connection for your users into the mesh. So this can be with the web UI that we're going to see in a bit. It can be with a Slack gateway or REST API gateway, even event-driven gateways. The ability to connect into the mesh is kind of open to whoever wants to build a new way to access it, right? And then we have data connectors. We have a visualizer, which kind of gives observability into execution of agents, which is really cool. Our enterprise version also has this agent builder. So I don't know if I mentioned this before, but our agent mesh is an open source framework. But when we get into the enterprise version, we have this agent builder. So if you have business users that want to create an agent, but they don't know how to code, they can use the agent builder to build out their own agents, right? And that's kind of the format of how the agent mesh works. I will pause for a second to see if there's any other questions for me. I see a lot of conversation happening, which I really like.
No questions yet. It looks like most people are asking questions and getting them answered in chat, but everything else has been asked for you, so you're good to go.
I love an active community. It means I don't have to do as much work.
Exactly.
All right, so for the workshop that I'm going to show today, we have this this GitHub repo, and I think you have a link that you can post up onto it. But this repo actually has a step-by-step of getting the agent mesh up and running. And so I will be following in this repo. The other thing to note about this workshop is that agent mesh works on Python. But if you don't have Python or you don't want to do it locally, we actually have, let me see where I can find it. Right, when we do get into the literal workshop piece, we actually have a code space, a GitHub code space for you to run all of this. So you'd be able to do this within GitHub code spaces instead of on your local machine. So what is step one in getting up and running with the agent mesh? Well, so the backbone of the agent mesh is an event broker. And we do have like a dev version that allows you to just use local queues instead of an event broker, but we suggest leveraging the event broker itself. So you can actually go to console.solace.cloud and sign up for a trial account, and that'll give you access to an event broker for 30 days, and you can work with a lot of the cool technology that we have. Once you have that event broker, once you have that cloud account, you want to actually stand up an event broker service. So you would come to this cluster manager over on the left, and you would click the add service, give it a name, choose a cloud and a region, whatever works for you. I'm in the great American state of Canada, so I pick that one typically. You can keep developer as your service type. It's going to give you more than enough capacity to accomplish these tasks, and then click the create service button. That will take a few minutes to set up because it's actually spinning up a lot of stuff in the back end in order to get your broker up and running. But once you have that broker, you can actually get into the agent mesh stuff itself. So that's your sign up right here. This cloud setup is your sign up that I just went through quickly. And then your SAM installation and configuration is this one right here. So if we go past the code spaces part, because I'm going to work locally, we will start by actually installing the Solace Agent Mesh. So because we are working with Python, we actually want to create a virtual environment. So I'm going to create a virtual environment and activate my virtual environment. You know, I find the part that always goes wrong the most is typing when you're doing live coding. It's pretty funny. And then once you have your virtual environment, you can install the Solace Agent Mesh. So that will take a minute or so to install. And I'm trying to see if there's anything else that I can do in the meantime. You know what? While I have a minute, I can actually show you, once you get your broker up and running, you can start looking into things like, you could see the queues that come up and running and the clients that come up and running when you are required metrics. That's an interesting one. Never seen that error before. But when you have the agent mesh up and running, you'll be able to see the queues and clients that it actually creates in order to connect your agent mesh into the event broker. Cool. So now that I have this installed, I can do a -V just to make sure I have a version here and I installed properly, which is taking a fun minute to get done. Okay, 1.11.1, perfect. So now what I want to do is I want to initialize my agent mesh. So I do sam init -- GUI. And that actually gives you the ability to initialize the Solace Agent Mesh using a GUI instead of through code. And of course, that opens in the wrong browser. So there we go. Yeah, I think there's a link up there now. Perfect. So for this example, we're going to do the advanced setup because this actually allows us to specify our event broker. Advanced setup, click next. We're going to give it a namespace that makes sense. I always like to put workshop just because it's the easiest. And then we're going to say existing pub sub plus broker. Now you'll see here there's a URL, there's a VPN, there's a username, and there's a password. So in order to get those, once you're in your cluster manager like this, and you see your event broker, you can go to the Connect tab, and then filter by protocol. You want to do web messaging, and you can click JavaScript, and you'll see over on the right-hand side here are all our connection details. So we can copy this URL and paste it here. We can copy our VPN and paste here, copy our username, paste, and then finally copy our password. Click next, and now we get to provide our our LLM. So we support OpenAI, Anthropic, Google Gemini, Azure, and pretty much any provider that is OpenAI compatible. So we actually have one that we use called Light LLM. We leverage that, and now I get to try to figure out the super secret way to get my key without letting everybody else see it. So that's on the back. Okay, good. And I've pasted that in here. And then just for my own, I'm just clearing my history like that. And then you get to choose your model that your supplier supports. So I'm going to do Claude 3.5 Sonnet. Does a test to make sure it connects. And then here's the configuration for your orchestrator. So one of the things that I showed here is we have an orchestrator in our agent mesh, and that's where typically the tasks go to. So when you're using, let's say, the web UI and you ask a question, it'll go to the orchestrator. The orchestrator breaks it down into subtasks and communicates with the agents in order to accomplish the task. So we can leave all of the defaults here for the orchestrator. This is just artifact servicing and the agent card. So A to A uses agent cards in order to describe what the agent can do. We click on next, and then here we can add our web UI gateway. We're going to actually add the web UI gateway because it gives us quick access to actually see and interact with the agent mesh. So we're not going to change anything there. Oh, yes, sorry. We need to put a super secret key, which can literally be anything because it's just a session key that's used as long as it's not super easy to figure out. Here's all of the information. And when we initialize the project, what actually happens in the back end, which I can do here. Yes, I trust the author. So what happens in the back end is it creates all of these files and configurations to actually get the agent mesh up and running. Now you can go into your folder and kind of inspect through all that at your own leisure. But for the purposes of the workshop, let me do this. Yeah, so once all of that is done, we can actually run our agent mesh. Yeah, so we can come back here and we could say SAM run. And then you'll usually get a lot of log lines here. This is all just connection with the broker and a communication that goes between everything. So once you have that up and running, you can actually navigate to localhost 8000. And that will give you access to the web UI gateway that we created. And you now have access to the Solace Agent Mesh. So we can see here, we have the orchestrator agent and we have the mesh, and we can start by asking questions just like, what agents do you currently have access to and what can they do? So it retrieves information. One of the cool things that you have is we were talking about observability. So if you come over here to the workflow, you can actually see the call, every communication that happens with the Solace Agent Mesh. So the agent, the user went out to the agent used the LLM, asked to list artifacts, and then came back. So that is the agent mesh that's up and running. Now what we can actually do is we can explore agents themselves. Can I use Olama for the mesh? I just saw that one come up. I believe you. So any LLM that supports OpenAI, if you can connect to it with OpenAI, then you can leverage it. You will likely want to do some experimenting with each model as it comes to its capabilities for things like the orchestrator agent. So I haven't worked a lot with Olama. I don't know how well it will be at breaking down tasks and accomplishing them. But if you're using it on a provider that supports OpenAI, then you can certainly get it done. Okay, so let's look at adding a new agent. So if we come back to here, I'm
I
going to
think you got one more question. Someone was
yes.
asking if you could explain how it can prevent message loss and handles huge traffic.
Yes. So that goes a lot into our event broker technology that it would take way too long, and I kind of don't want to get into here. But as an example, Solace has been doing event broker work for the last 25 years now. We started out with hardware brokers that were leveraged by stock exchanges and financial services. We moved into using software brokers as well. So we have our software broker you can deploy in pretty much any environment. And now we actually have Solace Cloud, which is what you were seeing for sign up there. So over the time of doing that, we've learned how to be extremely efficient in terms of things like message loss. Guaranteed messaging is a feature that's in our brokers. Huge traffic is something that our brokers are used to, depending on what you're using to implement your brokers. We had RBC is one of our clients, and I think they recently surpassed 118 billion messages a day on our event brokers. So it's something that's really built into our technology.
I think you got one more question too. Someone was asking, what is the element that puts restrictions on the agent, such as renaming a chatbot that relies on Gemini's API but identifies as a custom name?
Yeah, so that kind of gets into the customization of the agents themselves. I'm going to go through a piece now where we add an agent, and then we can dig into where all of your configuration and customization for that can happen.
Those are all the questions. Thank you.
Okay, cool. All right, so I'm gonna duplicate this tab actually and reactivate my environment. Activate. Okay, and then I'm going to run SAM add agent, and I'm going to say give me the GUI so that I actually get a point and click implementation. Now, this is adding an agent. We're going to add an agent that actually leverages some of the built-in tools that come with the agent mesh. So if I come back here, we could say we want a new agent. We're going to call it built-in agent. And give it the same namespace that we were working with. And then model type here, we have a few different models that you can use that you would supply in further configuration. There's configuration that happens in some of these files like shared configs where you can actually add new models in. So you can see we have like a general model, an image model, and right now they're kind of all leveraging the same thing. But you can customize those using the shared config. We're going to just use the general model for this built-in agent. We're going to say it supports streaming and then move on to the next. We're going to define which artifact service we want to use, which we're going to use the default. And artifact handling, we're going to keep that as a default. And then here we can see some of the custom tools that we have. So we have artifact management. Other built-in tools include things like audio, data analysis, general image, internal testing and development, time-related tools, and web-related tools. So for this example, we're going to add in the data analysis tool. We will add in the general tool. And it's actually a group of tools. It's not just one, but we'll add in the internal one. And then we will add in the web tool as well. This is just an example of adding in some of the built-in tools. And then we'll look at things like our catalog in order to add in some cooler ones. So we'll say, yeah, just a helpful AI assistant. Keep all of this default here. And click next, save agent and finish. And so we now have our new agent. We just have to stand it up. So here is an example that I'm going to show where we are hosting the agents in the same place, which is going to be my local machine here. And yeah, that kind of answers that question from before. So I can actually do, if you notice here, I have the agent mesh running in one terminal. And you can see here we have just the orchestrator agent. But we can now run the new one we created, the built-in agent. And let that kick up.
Question. They're asking if you can deploy multiple models as well.
Yes. So there is the ability to deploy multiple models. It's part of the whole configuration. You can see here that in this YAML config file, I have like a planning model that leverages these specific models that are in my environment. I'm not going to open my environment variable because it's got API keys in there. But you can see that it's literally like you provide the model, you provide the API endpoint, and you provide the key. And so we have it. I think when you do the init that I was showing before, all of these environment variables are created while using the same one you basically did. Yeah, you can see here the general model and then, okay, image one and stuff. So you can specify different models for these different model types using environment variables, changing this config file around to create what you need.
Gotcha. And you got another question too. Someone asked, what happens if one agent stops working? Does the system break?
Right. So no, this is kind of an example I'm showing here where I'm deploying another agent, right? And this thing comes in, right? So now it's existing. If I were to come over here and I were to just kill this process, it's expecting, so it does have like a time, like a refresh loop. But what would happen is this agent would just disappear. Now, if you are leveraging an agent and it fails, one of the cool things about the fact that we're using an event broker as a backbone is that the request out to that agent goes into a queue inside of the event broker. And the request doesn't come out of the queue until a successful acknowledgement has come from the agent. So if the agent breaks down before it's able to complete its task, the next time it comes up, it's just going to pull that same task out of the queue. So the event broker gives that stability of when things go wrong with an agent, you're not screwed. Does that make sense?
Those are all your questions.
Okay. All right, this isn't going down as fast as I thought it would, but it works. Yeah, so that is the built-in agent getting up and running. So that was me creating an individual agent, and agents can be things, ultimately can be things like Python functions, MCP servers, any of those things. You can build any agent you want, and you can even deploy agents anywhere. As long as they speak A to A, then you'll be able to incorporate, or MCP. A to A or MCP, you'll be able to incorporate into the agent mesh. So with that one up and running, right, we can now go back and we can kind of ask that same question, right? What agents do you have and what do they do? Well, I'll show you a cooler one in a little a little bit. I know that these samples aren't very, very interesting. But okay, here's an example that uses the built-in. Okay, so it's actually, you can see here, it went to the orchestrator. And then in order to get more information, it's actually going to the built-in agent. So I think it was actually able to, it leveraged the data analysis component of the built-in agent in order to accomplish this. And you can actually click on and see what the call was, as well as the response. Cool. So that is an example. And now we can go into, into leveraging the catalog. So the catalog is kind of a way inside of the Solace Agent Mesh to see and implement pre-built agents. So if we come to here, I'm going to create a new tab again. And then I'm going to run SAM plugin catalog. And this will kick up a new a web UI that actually gives me a list. So it never opens in the right window, does it? Okay, here we go. So this is the SAM plugin catalog. And what this is actually doing as a plugin catalog is it's actually going out to a repository that has all of our core plugins. So at the moment, we have two different repos. We have our core plugins, which are ones that we support. And then we have our community plugins, which is ones that we don't have direct support on, but we want our community to be able to create and share and leverage these. And our plugin catalog, can actually close that one, gives you the ability. So it starts with the core plugin catalog, but then I can do something like take the community one and add the registry in by just providing the GitHub repo. And that will actually add in additional plugins. So you can see here, we've got a bunch of different, what we call plugins, which are essentially templates to creating an agent. And so for example, you can see that we have, what's a good one that we're going to use here? Geo information, right? So it's a plugin that provides comprehensive geographical information services, including location, time zone, and weather data. So we can add this new plugin as a weather agent. And once that's done, in the back end in the code, you can see under agents, we now have this weather agent, right? Another one we can do find my IP. So that'll be a location agent. We're going to call it that. And what's the other one? Let's do the mermaid agent. Where's that one? Oh, spelled that wrong. There you go. So this uses mermaid.js in order to generate visualizations. Oh, wow. My typing today. Okay, so now you can see in the code, we've got the mermaid agent, we've got the location agent, we've got the weather agent. And I'm going to kill the catalog now because I no longer need it. But now I can do SAM run. And I can specify these different agents. So I could say weather agent. I could say agents, location agent. Now, if you were to do like I did in the first one and say just SAM run, it actually looks and finds all of the agents and gateways that exist within the config files, and it stands them all up. But what you can do here is you can actually individually run these. And this is really great when you want to start doing things like containerizing your agent. So you can actually leverage the Solace Agent Mesh in a container for an agent and just stand that agent up using the same concept. So now that we've done this, we can go back to our agent mesh. And when we refresh our agents, you can see we now have all of these connections available. So now if we want to do something like, say, give me the weather in my local area for tomorrow. So you can see here in the flow, it's actually going out to the orchestrator agent, and then it's going to go to the location agent to use my IP address and see where I'm at. So it uses that tool right there, gets my IP's location, and then comes back, and the orchestrator is like, okay, what do I do with that information? So now it's going out to the weather agent to actually pull the weather for my area. So it takes the speed that it's bound by is the LLMs that you're using. I mean, I guess technically as well as whatever hardware you're running the event broker on. But there seems to be some technical issues. Oh, wait. Weather service is currently experiencing problems with its geocoding service. Alternatives, local weather sources. Okay, so that didn't exactly work. There was an issue with the weather API. It's also possible, if I look here, if I look in the config, I might need to leverage an API key. Yeah, so it's possible that because I've been doing this demo a couple of times, making sure that it's ready to go. It's possible that I locally used up whatever freebie I had with them, and now this service isn't working properly. But this is just showing the example of everything. You can see, I don't know if there's any files that were no, there's no files that were generated from this. But if you could say, here's an example that they have. Create a bar chart showing the population of the 5 largest cities in Australia.
You got one more question? Someone
Sure.
asked, will adding access points introduce noticeable response delay? If so, what are the most extreme ways to minimize it?
So because we're leveraging an event broker and we're doing streaming that way, your delay is only really limited by the hardware that you're leveraging. Because our broker is very efficient in piecing handing these things off. I can show what's happening in the back end. So when my web UI sends a request in, what it actually does is it simply publishes a message into the broker. And then I have one of these queues, not located. See, you're seeing in these queues, there's the name of the agent in each one. And there should be one that's actually me, which is the one of these two gateways. So it gets pushed into the orchestrator agent right here. And then the orchestrator agent handles it and pushes a new message into one of these queues. So it's doing a lot of back and forth traffic. So things aren't being held up by individual requests happening.
Sounds great. No more questions.
Yeah. So if for example, everyone is leveraging the same agent that's being run, one of the cool parts about leveraging an event broker is you can actually stand up multiple instances of the same agent. And because there's multiple instances that are all subscribing to the same queue, and the way queues work is that they're taken by clients one at a time, then you can have multiple agents, multiple instances up and running of the same agent and still handle the load. So scalability is something that is very easily handled with the agent mesh. Oh, I made a request, didn't I? Okay, here we go. So if I look at my files here, I could see, yeah, okay, so Mermaid actually made a thing. It went out and found the information, or it had the information. Yes, apparently it already had the information, the model, and so it just used Mermaid to create that. Oh, I guess my timing wasn't too bad. That's pretty much I have at the moment for this. We have our Solace community. I don't think I gave you that link. I'm really sorry. But it's community.solace.com, where if you have questions, you can go there. I'm also going to be sitting on the Discord. So if anyone has questions, they're more than welcome to ask me or ask. I can't remember how that works. Do they ask questions into a specific area in the Discord and then it comes through? I'll figure that out. Anyway,
Yeah,
if you have questions. Go ahead.
They can ask questions on the Discord. They usually ask it in general, and Siddharth sometimes will like at you if something does come through.
Yeah.
But I also think if you have some time and you want to, we can just use this as like a Q&A session and just have people ask the
Absolutely.
questions.
Yeah, for sure.
Great. You've already got one coming up. Someone said, what will be the best use case?
So we have a few of them. Let me see if I can see Solace, what we have up on solace.com about that. I know that we have a couple of people in production, a couple of people doing pilots. Fulfillment centers is a big use case. We are also looking at someone actually is demoing right now with predictive maintenance. So we have like hardware and industrial people that are experimenting with predictive maintenance, people in the gas and oil industries that are looking at using the mesh for predictive maintenance, which is a really cool one. Let me see if I can find that platform. Here we go. Autonomous customer support. That's kind of a big one with agents, but with multi-agent, you're able to have different areas of expertise that each agent can hit. And then the orchestrator actually handles all of that, which is pretty cool. Yeah. Supply chain is a big one. Marketing and sales agents. Any other questions? Let me see if there's anything else.
I don't see anything for now, but you gotta thank you.
Cool.
If y'all have,
yeah, go ahead.
oh, sorry, go ahead.
Okay, so I think what I can do really quickly is get and just show really quick, because if you get into doing this and you want to do some configuration work, everything sits inside of those config files that I was showing. So let me get that up and running again. So typically what will happen, and I think we're kind of working on a UI way to do this, but we're not there yet. But one thing that you could do is, let's say I wanted to have an agent that goes out to like a MongoDB collection. And so I have this Mongo plugin. So I'd create like a Mongo agent out of it. And then typically what happens is this installs a YAML file with kind of the basis for what you're going to do with your Mongo agent. And then you can come in here and you could see in the apps section, you can see where it starts leveraging these environment variables. So you would want to actually replace these environment variables in your environment file, or wherever your environment variables sit for your cases, with the information that's actually necessary for these. And then in terms of if you want to try connecting an MCP, you can actually see in our community plugins here, one of the hackathons that we did a couple of months back, some people were actually creating these MCPs. So for example, they have like a Bright Data MCP that connects, that leverages, a Bright Data plugin that leverages Bright Data's MCP. And so typically what happens for an MCP server is that the biggest thing here is this config file, because this config file is where you will plug in the information for the MCP. So let's see, it's an MCP tool type. This one leverages standard in and out, and then you provide the information here, and then you can see it's expecting an environment variable. So that is in our community plugins is kind of a few good examples of how you can easily stand up an MCP plugin in order to connect an MCP into your agent mesh. Not saying that that's associated to any challenges that you might see here during Global Hack Week, just like a random thing that came up, right? All right, I think that's everything that I can push here in this workshop. But if anybody has any questions, ask them, or reach out on the Discord, and I'll help make sure that you get things up and running smoothly.
Yes, that's great. I'm checking the chat. I don't see any other questions, so I think you are good to go. It was a great stream, and a lot of people were interacting in the chat and like sending links to each other and going back and forth and talking about a lot of different questions. And this is one of the most engagements I've seen during a stream. So definitely a
That's
good kudos
awesome.
to you. Yeah, most streams are like maybe one or two comments, or like it's mainly just the streamer talking, but like people were going back and forth. So honestly, really great job. I do have someone requesting for your LinkedIn if you feel comfortable sharing that.
Sure.
Yeah, and if you want, you can put
Let's
that
see
in our
where
chat and I can
that.
paste it over into
Yeah,
the
for sure.
comment
Do
section.
that. So you can look me up. I am Ray Riel on
Yes.
LinkedIn, and that's my link right there.
Perfect. I'll send that over, and and I would definitely stick around for maybe 1 or 2 minutes just so you can see your flowers coming in. People are saying that's an awesome stream. They are thanking you because you did an absolutely amazing job. So I'll play some background music just to see if anything last minute comes in and to see you get all those thank yous showered through. So we'll just chill around for a little bit.
Sounds good.
Play
Thanks.
some background music. Of course. Someone saying, thanks, it's awesome. Lots of great comments. And they'll be coming. There's like a slight delay between Twitch and YouTube's comments into StreamYard, so it'll be a bit, but they will be coming in. Someone said it's very informative and cool.
Awesome. Here. This is what I'm gonna do. That's what we'll go with.
Whoa, I like that. That's good.
Yeah, I'm kind of
Better than the winners.
a bit of an old school, so I use Alfred app on my Mac, but I hear there's a new one, like an AI one that kind of replaces Alfred app.
Oh, I like that. I don't know if I would trust the AI version of that. I feel like it would give some weird graphics at some point.
Yeah.
This is like better than our banner though. We had like a banner up for like a
Oh,
ticker at the bottom. And I think
oh
that one's
yes,
like
there you
more
go.
on the screen. Yeah. Ooh, you've got some good thumbs up emojis.
I'm supposed
Thank
to
you
add a
for
way
the
to
wonderful session.
offload a single task over several agents rather than pressuring one. Well, so typically the way that it works, if like you, did I have a different one that I was doing? Let me see up here. I think there was one up here, right? Look at the workflow on that one, right? So what actually happens is that the orchestrator takes in the task and breaks it down into subtasks, and then sends each subtask off to agents. So agents aren't really being pressured with large tasks. They're more being pressured with the broken down smaller subtasks, if that makes sense. One of the things that we do have, or that we're working on, I think it's on our roadmap. I'm not sure if it's in yet, but it's open source, so they're constantly updating things. We are working on parallelism. So the ability for multiple agents to do things at the same time. It's not there yet, but it's coming.
Okay, so up to you. We can hang out for a bit longer and see if anything else comes up, or you can log off early. It's up to you.
How much time are we? Yeah, 8 minutes.
We've got about 8 minutes, so completely up to you what you want to do.
I don't see what the numbers are when it comes to, at least when it comes to Twitch.
Yeah, so you've got about 53 people watching, 45 people are on Twitch, and 8 people are on YouTube. I will say sometimes those numbers aren't as accurate. They can be a bit lower, so
Yeah.
you could have even more people. Looks like Electroman enjoyed that explanation. They said thank you.
Awesome. It'd be interesting. I want to go back. I clicked in on the Auth0 stream that happened, and there was some really interesting stuff in there. So our enterprise version of the agent mesh actually incorporates OAuth for authentication and authorization, and there's actually also built-in role-based access control, both at the agent and the user level. But a couple of the things that I saw when I clicked into Auth0 would be really interesting to see how we could leverage that in the agent mesh as well. So I'm gonna have to go back and watch that one.
Yeah, did you know that all of MLH's live videos are actually recorded?
I hope so.
Yeah, yours is actually recorded too. But if you go to Major League Hacking's YouTube channel and you click on the live section, all the videos are recorded. So if you scroll down, you'll be able to see the Auth0 stream at this link that I just put in the chat here.
Let's do that there. Cool, perfect.
Yeah, so it's fully recorded, and it'll be up there for forever.
All right. Well, I'm not sure anybody else is going to be asking questions at this point. I think they'll probably go back through, maybe do the workshop, and then I'm sure they'll have questions later on.
Exactly, yeah. So we can log off. Thank you, everyone, for joining. We've got a couple more streams coming up, so definitely make sure you join. And if you have any feedback for us, we would absolutely love to get your feedback. So just a couple last closing things before y'all log off. So don't log off too soon. We're going to push up the next stream that we've got for our Global Hack Week, and that is our Figma stream. And that is happening in Actually, I think that's happening in 5 minutes. That's at 3 p.m. ET. So definitely make sure you check in for that event and check out our schedule. On the topic of streams, if y'all are interested in giving us feedback for this stream, or honestly any stream that you've been to this Global Hack Week, or just for Global Hack Week in general, please make sure you fill out our feedback form. It is very, very useful to us so that we can get your feedback and improve Global Hack Weeks for you in the future. So definitely make sure you check out the rest of the streams, and let's give a big round of applause to Ray for their very first stream that went extremely well and had very great engagement.
Thank you.
Of course. Okay, so I'm going to end the stream now. Thank y'all for joining. If you have any other questions, just make sure you ask them in the Discord. Bye.
Awesome. Have a good one, everyone.